Okay, this is video number 2 going for systems of linear equations. And we're going to talk about algebraic methods on this one. This is just for substitution specifically. So if we take a look at our system of equations here, we want to look for, ideally, one of the equations is already solved for. By that I mean it's either x equals currently or y equals currently. So if I take a look at these two equations, one of my equations is y equals already. So what I'm going to do is I am going to circle the variable that is by itself, and then on the other side of the equal sign, I'm going to go ahead and put parentheses around what it's equal to. I'm going to go down to the second equation, find the exact same variable that you circled. So I circled a y, which means I'm going to find the y and I'm going to circle it. Now, everywhere I see that circle in the second equation, that's where I'm going to put the parentheses in. So if I go through and I start writing this equation, it's going to look just like 4x plus, but then the y is going to come out, and that's where my parentheses are going to go. So I'm going to put my x minus 4 in there, so that's what I'm substituting in, and then I'm just going to go ahead and continue writing the rest of the equation, so equals 26. I know substitution is successful if I take a look at this, and there are only one variable in this equation. So if I go ahead, take a look at this, I'm going to combine like terms. I can put the 4x and the x together, and that gives me 5x minus 4 is equal to 26. Now we know how to solve this. So I'm just going to go ahead and move my 4 to the other side. That's going to give me 5x is equal to 30. If I divide by 5 on both sides, that should give me x is equal to 6. Okay, but the solution to a system of equations is a point of intersection, which means we need an ordered pair. We need an x comma y, or whatever variables that were given to you in the original questions. So if I take a look at this, I have an answer for x. If you look back at the original equations, technically had two variables. So at this point, you're going to go back to the original equations and choose the one that you prefer. When I'm doing substitution, I actually like the equation that I plugged into the other one. So it normally requires just a little less work. So everywhere I see an x, I'm going to plug a 6 in, since that's what I just found. So I got my answer here. Oh, that's dark. Let's get rid of that. So I found my x here, which means I'm going to plug it in here. All right. And then I know that 6 minus 4 is 2. Now you're not quite done. You need to make sure that you write your solution as a point. So our solution is going to be, we're in alphabetic order, 6, 2. Okay. Moving on to the next one. I am going to go ahead and solve this using substitution. However, it doesn't look like it's set up for substitution, but I can do it. So I'm still going to do the same thing. I'm going to look for a variable that is either by itself, so x equals or y equals. And if there isn't one, I am going to find a variable that I can easily get the x or y by itself. And by that I mean I just want to do addition or subtraction to move something from one side to the other. So if I take a look at the second equation, I see that the second equation has just a plain old y in it, which is kind of nice, a positive y right there. So I think what I'm going to do is I'm going to take this equation and I'm going to solve for y. So I'll take this guy off to the side with my 4x plus y is equal to 20. And I'm going to get y equals. So I'll move my 4x to the other side, get those guys to cancel. So I'll get y is equal to negative 4x plus 20. All right, now this is y equals. So I'm going to go back and kind of do what I did before. So there's my y. I'm going to put parentheses around this guy. Go back to the other equation, not the one that you just solved for, and circle that y. So I think what I'm going to do, since I'm kind of done with this equation for now, is I'm going to erase the green circle that I put there so I don't accidentally plug it into the wrong spot. All right, so now I'm going to start writing my original 2x minus, there's the y, take it out, go ahead and plug in what we just found, which is negative 4x plus 20, close the parentheses, and then continue writing the rest of the equation. So 2x minus, there's my y, equals -2. Now if we take a look at this, I see that I need to distribute this negative sign here. So I'm going to go ahead and multiply that guy through to everybody so I can get rid of the parentheses. So that's going to give me a 2x plus 4x. That becomes a minus 20, and then carry down my -2. You'll see that I only have one single variable in this equation. This is good. Let's go ahead and combine like terms. And then let's solve for x. So I'll move my 20 to the other side. Those are going to cancel. That gives me 6x is equal to 18. If I divide by 6, I then get x is equal to 3. All right. But remember, you need to find an answer for all of the variables that were given to you in the first place. You had both an x and a y. Go back to the original equations, or you can go back to the one that you solved for y. I like to go back to one of the originals because I don't want to accidentally use some poor work. I think I'm going to use the one that I just circled in purple. So I'm going to plug this into my new purple equation. So 4x plus y is equal to 20. And honestly, I only chose this one because everything was positive signs. It doesn't matter, though. You could do the other one. Actually, it doesn't matter which one you do. You'll get the exact same answer. So make sure that you plug in the x, since that's what we found. And then go ahead and solve for y. Cancel those. And that's going to give me 8. Remember, you need to write your answer as a point. So our solution is going to be the x value we found, which was 3, comma the y value we found, which was 8.